Hello all and welcome back to study duality. So we are in chapter 8 of the lecture notes, linear programming with SPICE, and we are in part 2 of chapter 8, duality theorems. So far we have in this section explained what the duality is formally. So if we have a primal LP or any LP, we call it a primal in this duality business, 820, and suppose it's given in a standard form, then its dual is in dual standard form like this. So maximization becomes minimization, constraints become objectives, objective becomes constraints, upper bounds become lower bounds, technology is transposed, so rows are turned into columns and vice versa, and sign constraints are kept. We had an example how to perform the dual transformation. A small remark on the fact that unlike the previous section where we looked at the same LP in different forms, now we have two different LPs. So primal and dual are different problems, but as we shall soon see, they are very closely related. But before going to the main point of the duality, let's have a remark 8.24, which says that the dual of dual is primal, which is theoretically interesting, and also from the practical point of view it is kind of nice that this transformation that takes the primal and then constructs the dual is kind of its inverse is in some sense itself, or we can look it backwards also. So the idea is the following. Suppose we start with the LP, and let's assume it is standard form, why not, we can always do that. Then we transform it into a dual LP. Now the dual LP is of course an LP, so it also has a dual. So what happens if we start from primal, make a dual, and make a dual again? And the funny thing that happens is that we are back where we started. Okay, this might be trivial, this might be easy to see, I don't know, but let's argue it and somehow formally that this is indeed the case. So we start with a primal. We start with this thing here. Okay, we transform it into dual, so now we have this thing here. So we start with 820 and we have 821. All right, let's get back here. So now we have this. All right, this is an LP, and we can perform the dual transformation again. And typically it's, as I said, it may be not so clear how to do it from this. So let's transform this first to a standard form LP. Okay, so this is the algorithm 8.10. Okay, let me show you the algorithm again. So this is this red box. This is what we are following. By now this should be very familiar to you. So let's get back here. So standard form, what we have to do, minimization turns into a maximization by multiplying just by -1. Upper bounds become lower bounds with the same thing, multiply by -1. And then, yeah, I think that's enough. Okay, so Step 1, algorithm 8.10, change the objective, so minimize W is maximize minus W, B transpose Y becomes minus B transpose Y. So that was step 1. So now this LP is in equivalent form this LP. So what was the step 2? Step 2 was to remove double inequalities. We don't have them here, so this is not needed. So step 3, this was to remove lower bounds, if I remember correctly. So everything should be upper bound. So this is here we have A prime. A transpose Y is bigger than or equal to C. This should be the other way around. But this is, easy. You just multiply by -1 and everything goes around. So we get maximization minus W equals minus B transpose Y, and the constraints are minus A transpose Y are less than or equal to minus C. And the sign constraints are there. So that was step 3. Sorry about the small mistake. Steps 3 and 4 are not needed. So actually step 4 is not needed. Step 3, we just did it. So step 4 was to split the decision variables into positive and negative part if they were unrestricted in sign, but they are all restricted in sign, so that's not needed. Okay, so what do we have here now? We have now rewritten this dual LP into a primal standard form. Everything here is now in the standard form, and now we can just follow the rules how we change a primal form 820 to 821, the dual form. So maximization becomes a minimization, and this here goes here, this here goes here, and yes, everything is transposed. Okay, if we just keep track of the minus signs, and remember that if you transpose twice, you get back to where you started. So the transposing is the similar kind of transformation as a dual transformation, that if you do it twice, you are where you started. Okay, so this here is this. So here formally I should have a transpose, but I just didn't write it there because it's just itself. And yes, let's see. Now we have actually some kind of a dual. No, this is the primal standard form, but there are a lot of minus signs. So let's just cancel the minus signs. By what I mean by that? Well, first of all, min minus z something is the max of z, and the something minus, so minus minus. Here the minuses go away if I put here max, and here if I multiply both sides by -1, minuses go away, but this inequality turns around. And indeed, we obtain this is the same as maximum z C transpose x, Ax less than or equal to B. We see that this is indeed a primal standard form, and this is where we started. Alright, so the dual of the dual is itself. Let's have an exercise on this duality. So this is the kind of exercise you would expect to have at this point. So we have shown you what is the duality, and we have shown how to construct one. So let's have an exercise where you have to do something like this. So we have the following primal LP. Well, let's call just LP here. 8.16. It's this kind of form. It has not many constraints but lots of variables. You may guess that in the dual way of looking at it's the opposite. And yes, what you have to do is to find the dual of this LP. And yes, as I've always said, that it's extremely helpful, I would say, not strictly necessary, but helpful to rewrite this LP first in the primal standard form by following the algorithm 8.10. You don't have to do this. You can find out the dual of this. Yeah, actually, I would probably use some cheap tricks and not understanding this as a primal standard form, but a dual transform and going to the other way around. So taking this as a dual and finding out what this is primal, which is, as we now know, is the same as the dual of this. But if you are confused or didn't understand exactly what I just said, then follow the hard or let's call it the laborious way, where you have to do a lot of work, but you don't have to think so much. So transform this into primal standard form and do the duality transformation there. All right. So we have still a little bit of left in this chapter, and that's the most important part. So let me keep this video short and let us go through this important part on a separate video. So in the next video. See you there. Bye.